Here's a slightly more complicated equation and inequality. We have on the left x cubed minus x squared minus 6x plus 3. So this is a cubic graph. And on the right, we have a quadratic x squared minus x minus 3. And we're going to look at the equation, or an equals, connecting them, and then we'll look at an inequality connecting these two statements. So I've graphed them both. We're familiar with the quadratic graph, so you can see the bowl-shaped curve here in blue would be y equals x squared minus x minus 3. And then the cubic graph has a little bit more curves to it. That would be the one here in red, y equals x cubed minus x squared minus 6x plus 3. To solve the equation, we want to look at where these graphs intersect. And because they're more involved, the cubic has more going on, we will have more intersection points. When you get equations you're not as familiar with, make sure you expand or condense the graph to see all of the intersection points. I've actually shown them on the clip that I've given in the handout, but our first one on the left, here, our intersection point here would be at -2 and then 3. So -2, +3. It's the x value that we're going to care about for the solution. Continuing on, you can see the next point of intersection as we move to the right would be here at +1 and then -3. And then continuing on, we have our third intersection here at 3, +3. So we have 3 intersection points. Our solution to the equation, our solution set, I should say, because there's multiple solutions, would be the values for x at those intersection points, -2, 1, and 3. And remember, because we're looking at the individual values, we'd use braces. So that would be a set of 3 individual values. We could check those by plugging those individual values back into the equation and making sure we get a true statement and that both the left and the right-hand side are equal. When we have the inequality instead, and notice this case it's a less than or equal, we would be wondering where the cubic graph, where is the cubic graph underneath the quadratic graph? Remember, the cubic graph is the red graph that has more curves to it. Where is it under the blue graph? Okay, to be under the blue graph. So let's take a look at that in this graph. So starting from the left, because it's fairly complicated, let's start on the left and move our way over. So starting on the left, the red graph is initially underneath the blue graph, which is what we want. But then it goes up above the blue graph and doesn't come back down until you get to x equals 1. And then it's down below briefly until we get to x equals 3. After that, the red graph is above the blue graph. So we actually have 2 regions where the red graph is above or underneath, below the blue graph. So we're going to use those 2 regions as our solution sets. They are separate, so we have to show them as a union. Whoops, my program froze up again briefly. Hopefully you can see it again. Now, let's go ahead and start with the one on the left. This shaded area on the left is going out to the left, so we are going to start with -infinity, and we're going to go up to where it crosses, which is at an x value of -2. Because I have an equal sign in this inequality, I'm going to let it be equal to -2 with a bracket. Then I'm going to union that with the other set where I have solutions, which starts at x equals 1, again, because of the equals, I'm going to use a bracket, and goes until x equals 3. Use the bracket again because we can be equal. So our solution set for the inequality includes 2 regions, -infinity to -2, including the endpoint at -2, and 1 to 3, including the endpoints of both of those. Again, you can check those by simply plugging in a value in each of these sets and making sure it makes the inequality true, which would mean that the left side value needs to be less than the right side value. I'll leave those checks for you.